and in my compilers class till now. And this is the only class which I'm really enjoying at this point, because I don't know what's happening in OS. They're just putting weird assignments. But yeah, so we were assigned, basically we had to build a language of our own and then build a compiler for it. And then it's still in the process. We are yet to build the intermediate code generation, and finally it's like compiling to a real assembly language. But yeah, I've more or less figured out the design. So I'm just gonna run some tests first. So this was like the logs from the previous run. So but I'm just gonna clear this. I'm gonna run a few things. So first I'll just run a test, so for my sanity. Yeah, right. And so yeah, it's functioning okay. So what are these things? These are just samples, basically like sample codes, and I don't need this right now. I'm just gonna, because it also prints the program itself, so it will be fine. So I'll be okay, python 3 and .py, and so I'm just gonna put in whatever sample I want to show. So this will sample1.txt, and that's a bad spelling. Okay, cool. And so this is the program. It looks like this. So in reality the program is just a text file, right? So it's like this, but it syntax highlights it and all of that. So this is how the program should look if you were like using this as a proper language in VS Code or something. It would just highlight all of it, and then it outputs none because it's literally just printing none. So pretty obvious what's going on. I'm gonna run all these samples so that you can get a better understanding of what the language is capable of. So this is passing in a bunch of arguments, and it has a run statement. So f times 2 is just this function run twice. So if there's a return statement, even that will be like copied twice, so then it's not really useful. But for functions like this, it's probably very useful. So yeah, like if you don't pass an argument and you're still referring to something else, right, some variable which is not like a local variable at that point, then you just go to the previous scope, and in those kind of cases you can really just like build blocks and then run these blocks 1,000 times without actually having a for loop in there. So it's pretty useful for like writing clean code. So I'm gonna run sample 3 now. So this is just Fibonacci numbers. I have a function which takes in a list, and then it updates the list to like further the progression for Fibonacci numbers. And then so like after 3 iterations, these are the 2 Fibonacci numbers which I have. So initially it was just like 1 1, and it was like 1 2 after the first iteration, and then so on. So after the third iteration it's just 3 and 5. Alright, so then I have sample 4. So this is once again another function for Fibonacci numbers, except it's more direct. It just evaluates the 4th Fibonacci number or whatever. Yeah. Okay, then I have sample 5. So this is going to be complicated. So there's a thing called I think enclosure or something in programming languages. So basically, if inside of a function you define another function, that function can use the attributes of some other function as static variables. So basically when I say print x, the x it will refer to is not some non-local thing outside of the lexical scoping. Instead it will think of x as whatever argument I gave while running f. So when I say g equal to f of 1 and I print g, it's going to be this thing. It's going to be algorithm print x where x is 1. It won't actually look outside of the scope to figure out what x is. It will just say x is 1. So when I run g with x equal to 2, which is happening at the last 2 lines, so it's going to print 1, not 2. So Python has this, test it out, and almost all languages have this thing. Cool. And similarly I have another function exactly like the f function, except I'm going to pass the argument g inside of it, and then it prints this as an environment, right? So it's not even an environment, it's like some sort of static attribute of the function. Okay, then you have sample 6, I think. So this is just basic arrays. I shouldn't even call it arrays, it's just ND arrays, right? NumPy ND arrays, and I call them as vectors basically. So you define a vector like this thing. If you try to print 2 times a vector, it will be just the elements multiplied by themselves twice, multiplied with 2, right? If instead I had a list over there, then it would just like concatenate the thing. So you can show that actually. You define list like this. So this is a sample 6. Yeah. So if I instead just had something like this, then what would happen is it will just concatenate the list twice. So you don't really need appends and all of these things, because it like just concatenates lists. So like whenever you want to append something to a list, you just do that. Pretty obvious. I have to yet put a delete keyword. That's one thing which is missing, so that you can delete a thing completely. But yeah, this works more or less. I don't have slicing till now, but that's okay, because you can just literally like make a new list and all of that, so it's okay. I'll have to put a pop statement at least, because this is kind of a necessary thing. Like if you want to run even a simple algorithm like DFS or something, you need to pop things from a list. So yeah, but okay, this was sample 6. Let's go to sample 7. So this is one of the more weird things which I have just put in because I like these things. So there's a library called termplotlib, and it allows you to plot stuff in the terminal as if matplotlib was plotting it. And so from that I just taken the plot command, and so what I'm doing over here is I'm making a list which is basically like line space 0 till pi with 100 elements, and then I'm calculating the sin x function using the Taylor series expansion of sin x, and then I'm just plotting x and sin x, right? And this is how the graph looks. Yeah, it's, I don't know. It's not even a proper feature. Like, I don't know. It's just one extra command called plot. That's all. That's all it's doing. It's just plotting like a 2D graph. So yeah, I should really put system call so that like the programmers can expand the language. But come on, it's just cool. Okay, it's cool, and that's why I have put it here. Yeah, call me stupid. So then you have sample 8. So this is just like a very normal thing. What is it doing? I don't really remember, but it was something. Yeah, it's just something I was using for testing, I think. So yeah, okay, this shows how the else function works. Sorry, the else block works. So you can literally like write else a bunch of times, and then it won't throw a compilation error, because I do not intend to throw a compilation error. All it will do is just it won't run the other else, because it already run one else. So it's like, okay, what the hell? You're saying otherwise. What does the otherwise even refer to? So I'm not going to run it at all. I'm thinking whatever happened before is okay. See, this only executes if the condition has failed previously, and over here the condition hasn't failed previously, so it doesn't run this one. Yeah, okay. So next I'm gonna run sample 9. So this is one which I was using for debugging, right? So you have sample 9 like this, and if I do some weird thing, maybe I just do a function call over here, right? Then it's going to print something weird. It's going to print a compilation error. Yeah, so it will be like incorrect print statement. This is not a correct statement, which is true. It's not incorrect. It's an incorrect print statement. I do it anywhere. Like let's say I do this plus some garbage value, like this variable is not defined, so it's gonna throw like this variable does not exist error, right? So it will be runtime error. This is not defined. Oh, okay. I'm also having a I have a print statement somewhere that's causing this problem. But yeah, the actual error is just undefined variable. Alright, cool. I'm gonna fix the print error actually first. So you'll also get to see how the code works or how it looks. So this problem that we had to face, it was most likely in the ID thing. So it's gonna print this thing. That's the problem. So this is undefined. I'm gonna put the undefined variable as whatever the undefined variable was. So it's x basically. And it's gonna format this and remove this print statement. Cool. And now it should work. Right. So it's undefined variable, whatever the variable name is. Cool. It's not showing where exactly did you use the variable, but okay. I mean, it's fine. You can't expect to do that. You can't expect me to be doing all of that, can I? So it's doing just an evaluation. I think that's the problem. It should just be a return at this point. So if I just make it a return, oh shit, okay, I can't make it a return because then things will be wrong. But still, let's just try to run it. Yep, thought so. So that's the problem. I still have to change all of that. But so it can't like really pinpoint the thing as of now, but I can still do things like these. So it's just a runtime error. Cool. For the evaluations, I'm just throwing away the error like that and not really figuring out where the error was, like what caused it, although I can probably do it. but yeah, whatever. I can at least print the line numbers. That shouldn't be too hard. Okay, so like for the tokens, just have a line number as well as a variable. Okay, as an attribute. But it's okay. We don't really care about all of them. As long as it works, it works. So this is okay. These are just like samples of the programming language. Like, we don't really care about any of this. What we do care about is how I'm going to use the programming language. So the way that I intend to use this language is, firstly I should show you like what does the language actually look like. So I'm going to run a very simple thing. I'm just going to say syntax.py, right, and I'm going to run sample1, and here I'm passing an extra argument. This is for the visualization, so it's going to build a visualization for us. And so yeah, okay, it did some weird thing over here. I'm going to control Z this thing. Okay, it doesn't kill it, so I'm going to kill the terminal. Okay, that's fine. Just add a new terminal. Yeah. So okay, what it did was it built an image. So by the way, this is some sort of weird error thing which I have, but so I'm going to delete this. It shouldn't really do that, but it builds this thing. So this is a PNG image which shows how the grammar derived the language. So you had let x equal to 8, then a semicolon, and then if x is 1, so it's equal over here, then right, so this is just a condition. So if x is 1, then you do a block, so it's like print 1 semicolon, and this statement does not have any children because it's an empty string that was passed into it. So like just think of it as something which I have done for my own convenience, but yeah, really don't think about it. And then you have this other bracket matching with this one. So you know, this is just basically whatever text we passed in. So this is the text, right, and this is the corresponding AST for it. So it's the abstract syntax tree. Cool. But all of this is good, and that's good and all, but how am I going to use the language? Well, so far I've been using it to solve project author questions. So this is first project. I'm going to close this thing because I don't need to do it. I can just literally, yeah, so I'm going to be like Python 3 pi project author 1, and boom, it solves the fourth project author question. And you can even solve it with hand, like, because it's so easy. But whatever, programmatically it's just easier. Like you can just do like 1000 floor division 3, 1000 floor division 5, add them, subtract 1000 floor division 15, just use the set properties, and this works. It's called something, I think it's called the inclusion exclusion principle, but whatever. So yeah, so then you also have the other project other questions, like this just counts the, I think it's the even Fibonacci numbers thing. Yeah, whatever. So I'm gonna run all of these project other questions. And this is finding the largest prime factor of this number. Right, okay, this takes a bit of time because this was a question with 10 power 6 iterations as the max limit. So I had to like reduce it to about 5 using some like math stuff, but yeah. So this is basically like finding the largest palindrome that can be broken as, so it can be factored as two numbers which are 3-digit numbers. And so in this case it's 906609, which can be written as 993 and 913 multiplication. Alright, I'm gonna run the fifth one. It prints this thing. So this was finding the LCM of all numbers till 1 till 20. And I'm gonna run the sixth one. And so this is a no-brainer really. Like it's just asking me to find out this value, s squared minus s2, where s2 is the sum of squares till n. So n included, like 1 plus 2, so 1 square plus 2 square all the way to n square, and this s thing is just a sum till n, right? So it's just asking me to print that. Of course it's going to be a positive value because, well, there's this thing called, I think, the RMS inequality, so RMS A inequality, but whatever, you know the thing, right? That I think we're going to use Cauchy Schwarz, whatever, we don't really care about that. But the point is that we are able to solve some CP-like problems with this language, and that for me is enough. Like you still have things which are missing. You don't have a delete function, so you don't have a delete statement. You don't have a pop functionality, but I'm gonna put all of that. I'm gonna eventually put all of that. But yeah, so as of now the language is more or less complete. Yeah, just need to add a delete statement, and then it would just be a complete thing. Like you can free memory, and at that point it's all good. Yeah. All right then. So I'll see you guys next video.